not only do I correct their spelling, but I do correct their grammar and their punctuation. So I'm in awe of people who do that full-time for a living. Because just the occasional time I do it, it's like, how do I tell them how to fix this? So, does this make sense, this problem to everybody? You see what's going on here? Because you're going to see your children doing a lot of this. It actually starts in grade 1, where they'll do versions of these problems with those snap cubes, the Unifix cubes. Here's the 4th grade one. So I'm going to draw a bar. How many pieces should I break it into?
5.
5? We agree? 5? How many pieces? How many of those 5 pieces represent the cost of the CD? 2. Can you sort of visualize a diagram? So it does look a little bit like this. Maybe mine's neater than yours. Got that?
Yep.
Now the child in 4th grade might very well just start putting 6s in the boxes. Because that's the more concrete way of approaching it. I, as their teacher, would move them toward writing a sequence with what I refer to as unit sentences. I would try to get them to write 2 units as 12, 1 unit as 6, and so on. Mostly because I know later, the more algebraic way of doing this is going to be 2/5 x equals 12. And I'm thinking ahead to how they're going to solve things that way. Because eventually there are going to be problems that you can't solve with these bars, or the bars will slow you down. This essentially becomes a bridge to algebra. So because I like doing these, I'm doing 2 more. Okay? So 2 people share money in the ratio of 2 to 3. They're sharing $80. How much do they each get? Or how much does Jill get? So imagine a bar for Jill and a bar for Bob. How many units will be in the 2 bars? 5 altogether, but 3 for one and 2 for the other, right? So perhaps something like this. In a sense, the diagram becomes a partial abstraction of the information that's in the question. So if I think about this idea of unit sentences, and I realize I'm going fast, it starts with 5 units equals 8. Agreed? And at this point, if I taught them mental math, I might say, you know, there's a trick for dividing by 5. You divide by 10 and you double the answer. Why does that work? Pardon? Right, you can essentially, if 5 units is 80, 10 units is 160. And there's a whole bunch of ways you can discuss it. So you can bring the idea of doing this mentally into the picture here. So you get 1 unit, and we're looking for 2 units, where the question mark is. So Jill gets $32. And then my favorite, oh, I guess I have 2 more. Do you want 2 more, or should I skip this one? Should I do this one or skip this one? Do it? Okay, who's got a pencil and paper? You want to do it or should I do it? Me? You can do it, okay. I like this is good. No, it's interactive. You know, it's fine either way. Let's do it this way. Can everybody visualize what 3 bars here would look like, 1 for each person? In other words, I'm going to do a bar for Jared, a bar for Seth, a bar for Juan, right? It's going to be 3 units, 5 units, 7 units. So something along these lines, okay? Notice my bracket with the question mark tells me this is what we're looking for. So I've got 5 units equals 45. There's no room on this page for any writing. If anybody's ever tried to make these things come up in PowerPoint, it's really challenging. And you eventually just run out of space. I was taught how to do this like about 8 or 10 years ago by a 3rd grade teacher in one of my classes. That's the only reason I'm able to do it at all. So it's 5 units equals 45. Each unit is 9. Jerry has 4 more units than 1. 4 times 9. Okay? So now we're going to make this problem seem really easy. You remember that one? So the rest of the story about this problem, by the way, is it was in the Boston Globe in September 2005. So I'm sitting in my living room drinking my coffee, reading the Boston Globe. This is an article on the front page about MPAST. And it had the easiest and hardest math problem and English problem. Easiest and hardest defined by most correct, most incorrect. And this was the hardest. So I just learned how to do these diagrams on PowerPoint. I was pretty proud of myself. And so I did this diagram and I mailed it to David Driscoll, who was then the Commissioner of Education. And we sort of knew each other a little bit because the Massachusetts Department of Education had funded a lot of the original courses I did. So I wrote to him and I said, this is not a 10th grade problem. In Singapore, it's a grade 6 problem. And he wrote back, he said, you're right. Which was, pretty good of him, I think. So how many pieces should the bar be broken into? 12, right? Because 12 is a nice number that you can get a third of and a fourth of, right? So I'm going to break my bar into 12 pieces. How many pieces will be grandstand seats? 3 for grandstand, or I'm hearing 3 and 4. 4, okay? 1/3 of 12. How many will be bleacher? And how many will be the rest? 12,500, right? So can you imagine this bar now? Right? See it? Do you see it? Okay, good. So here it is. Got that? So now I've got 5 units is the 11,250. Remember, we know a cool way to divide by 5? We double both sides and then we divide by 10. So I can get 1 unit. I'm not really fast on multiplying by 12, so I'm just going to tell you the answer. And so now I know the number of people at the game. Now, for the people who are initially, when they put their fingers up, were like 1s, 2s, and 3s, does this make sense to you? Good. Because what I like about this is I found there are people who lost in math when they got to fractions. There are people who lost in math when they got to algebra. And they can watch me do a problem in algebra and say, well, I believe you. But if you ask me to do the same thing, I have no idea why it works. And I find the pictures show people why it works. And often when I'm working with teachers and I go through these same problems, what I will also do is do each of these problems algebraically. Because I want them to see that this is not the end point, that there's a transition from this to algebra. Because our goal is really to get kids ready for algebra, not just to have them be able to draw diagrams. In the same way, base 10 blocks are a nice transition, but our goal is we want them to be able to add, subtract, multiply, divide fluently. We don't want them to have to pull out blocks that they're adding, 27 and 49, eventually. Along the way, they might have to, but our goal is something else. So, quick summary. Curriculum is more focused, and that's really consistent with what's in the Common Core. And I guess that's why I like the Common Core. Rather than taking sides on conceptual understanding is more important, computational fluency is more important, I think they're both more important. If you're interested in that issue, there's a great article by a guy named W. at Berkeley called Basic Skills versus Conceptual Understanding, a False Dichotomy. And he argues that they reinforce each other. And so I see the approach here as they reinforce each other. A big emphasis on problem solving, and to me the really more important part is higher expectations from children. That we're not saying, oh gee, they're so different in Singapore. They're so much smarter than we are. I think the DNA is roughly the same. That, the children there are capable of performing at a high level. I'm sure our children are too. So, I probably have more slides, but my voice is getting tired. So if there's questions, maybe we'll switch to questions. And I'm guessing some of the questions might be for me, and some I might pass off on you or save for later. So somebody back, yes.
What are the challenges for kids who don't start this program at the beginning and who are maybe now in 4th grade, say, and don't have the foundation? What are the challenges for them?
And I think the teachers tell me these challenges because if you're shifting from a program whose emphasis was teaching for exposure to teaching for mastery, and say you're in 4th grade, and ideally, as the 4th grade teacher, you can assume mastery of certain things. The first year or two, you can't assume that. And so you have to go back and fill in the gaps, essentially, and make judgments about which topics are the essential ones for continuation the next year, and which are less essential, and then you can take that time to fill in the gaps.
And is that very student-specific, or do you see patterns of the things that are not picked up?
I think it's a mix. So, for instance, in this country, we've been pretty sloppy, I think, over the past 20 years about things that I think are pretty critical, like mastery of single-digit multiplication. I mean, I've had times where I've worked with teachers, and in some schools they'll tell me half the kids in grade 6 don't have that kind of mastery. And I think, wow, it must be impossible to teach them about fractions and adding fractions from like denominators. So if you have a school system where those are the issues, then it becomes hard. The other issue that comes up a lot, and I think it's more of a problem as you move up the grades, and I have this problem in my own university classes. We've gotten a lot of our children so used to the idea that mathematics is only about getting the answer, as opposed to understanding what you're doing. That if you're shifting and saying, explaining what you're doing, understanding what you're doing is important, it's definitely a cultural shift for a lot of the children. And the only thing I can say there is I think that a lot of parental support on that is really important. That when you're working with children, that it not just be, oh great, you got the right answer, but can you explain what you did? And even a step further, can you explain why it works? So I think those kinds of habits are really important. So if, I know this wasn't your question, but I'm thinking that the kinds of things that if I was an elementary school teacher here, I'd want parents to do to support would be work with them on basic skills, like facts, but also work with them on explaining and conceptual understanding and explanations. You probably got more than you wanted. Over here? Software, yeah.
Does that inhibit, in your opinion, this formation of explanations and drive them more towards getting the answer right as opposed to come up with a reason?
I don't think I have enough of a knowledge base to answer that well. I think it would depend on the types of questions that are on the screen. I thought you were going to ask me whether it was healthy for them to be in front of the screen that long. Yeah. And my children are past the age of being in school, but now they have a grandchild. I would say to my daughter, who's got the grandchild, to limit screen time. Yes?
So, Montessori method is also very similar to this, but there they're using actually physical beads and...
Right.
So, would that increase, instead of having to see pictures of these things, but having concrete material in front of them, so when they're doing staging and stuff like that?
I believe there's a similarity. The question was similarity between this and Montessori.
Yeah, yes.
I'm not overly familiar. I mean, most of my knowledge comes from what I hear from teachers. And I know a lot of it is based on the use of physical materials. It's actually made me think about a lot of my own practices in my university classes. And even though it's described as concrete, pictorial, abstract, as if they're separate, discrete categories, I think of it as more of a continuum, that you can introduce a lot of ideas at different levels of abstraction. And I think in my own teaching that what I often do is, I know that I want to get to the abstract, because what gives mathematics all its power is being able to do things abstractly. But sometimes if I jump too quickly to the abstract, students just focus on what's the rule and formula to memorize, and they don't think about what they have to understand in the concept. So I find myself constantly sort of moving back and forth, depending upon the reaction of the people I'm working with. Yes? Well, both of you. I would say,
What's the question?
oh, thank you. What do I see as the changes at the college level if this happens at the elementary level?
Yeah, I want to know.
So, and I might have hinted at, I hoped I hinted at this earlier, but maybe not explicitly enough. My initial motivation for getting involved in this is what I see at the university level. Just huge numbers of students who are not prepared for college level math. It's almost as if their mathematical development stopped when they hit fractions. And so my interest is that I think if students leave 6th grade with a really strong foundation in what we now call number and operations, but it's also called arithmetic. I mean, in a sense, algebra is arithmetic with letters. And if you don't know arithmetic really well, it's pretty hard to do algebra well. So I see that the lack of this strong foundation has been standing in the way of what a lot of students can do once they get to high school and college. So I see this as potentially reinforcing a lot of mathematical opportunities for students, you know, as they move through the grades.
So you agree with this will help in the good?
Oh, yes. I think it's going to impact positively. I mean, I'm tired of seeing students pull out calculators to multiply by 10. I had a student last week, what's a third of 12 in college? I don't know. Okay? And it's not just one. You know, we have biggest problem in higher education these days is the huge amount of developmental education needed. I mean, roughly 25% of students need developmental education in math. To the point now where there's pressure to get rid of it. We have too many students taking developmental education. As a result, they're not finishing college. Let's get rid of developmental education, then they'll finish college. I should stay away from that topic. I get really But if you're interested in that topic, and you want to know how I really feel, Google my name and developmental math, okay? Published an article last week in the New England Journal of Higher Education. That way I can get across my point and not get my blood pressure up. Did you?
I'm curious. I was speaking with my son's teacher. She expressed a lot of anxiety and both her and her colleagues about teaching this new material and feeling like she was, in her words, one step of the students. Wondering what's being done to support their efforts in the classroom.
Do you want to take this?
question was that what are we doing to support our teachers in the classroom? Because this is a number of aspects of this program are new, and teachers are learning how to manage that. So there are a number of different things that we are currently doing and have done in preparation for this. So first thing is that, as I mentioned, we had some pilot teachers last year that have been working on this program and understanding it. And they told us last year when they started something very similar, that yikes, this is a little overwhelming, a little unsure of myself. And now they are the program's biggest advocates. And they're able to talk to our educators who are just beginning this and saying, you need to kind of get through this essential work in the beginning. It is tricky, it is overwhelming, but the outcomes are really worthwhile. So we have those folks in our buildings helping our teachers. We, thanks to the successful passage of the override, now have an instructional coach in every single building that's able to support our teachers, and they are both delivering professional development during ER days and PD days, but are also going into the classroom and helping them. Another thing that we have been working on is providing our educators with graduate level courses in the content of mathematics, so that they are really understanding and getting support in these areas. So, for example, over the summer we ran 3 graduate credit courses, K through 2, 3 through 5 in the area of mathematics. Dr. Bisk is teaching some of our educators this year in the area of mathematics. We have sent some of our educators out to conferences. At this point, I want to say we have about 85 of our elementary educators who have taken or are taking a 3-credit graduate course specifically in the area of mathematics in order to support their work as well. So those are some of the things that we're doing. And one of the things that's happening with the ER days, we have 5 of those this year, is that those days are dedicated to mathematics, so that our teachers are meeting at grade level, preparing for the upcoming units and looking at, okay, what are going to be the essential areas to focus on with each of these chapters, how are we going to present them, talking about challenges that are coming up, and our coaches and our pilot teachers are helping them to troubleshoot that. So also across the year, folks are working together collaboratively and with some of our in-house experts with support. So does that help? And one thing I did want to offer, and I know a gentleman was asking about our 4th grade students and students entering, and I'm sure that that can be an area of concern and question for parents. And so, as Dr. Biss said, one of the things our teachers are very cognizant of is that there are holes that we need to fill in. One of the things that these materials allow us to do is it gives all teachers access to all grade levels. So if they are working on something that they think may be a hole, for example, for bar modeling in 3rd grade, they're going to be starting that shortly. When the program initially was developed, it was designed so that students would have already had some bar modeling experience in early grade levels. So the 3rd grade teachers are now going back into those earlier grade level additions and teaching the students the basics of bar modeling. So that and these are some of the things that we're talking about in early ER days, so that how do we support our students that are coming into the program, not at the very beginning, but later on, so that we do have that on our minds and we do have strategies to deal with that. Do you want to take about 2 more questions? I'm happy to answer any other questions that have to do with the district. I know Dr. Biss does need to get going. So I'm going to have 2 more questions for Dr. Biss, and then I'm happy to answer anything else.
Interestingly enough, I was emailing with one of the editors at the publisher today. One of my suggestions was, how to write a book that's a teacher's guide, that's a parent parent's guide to all this. And I thought there was a need for that. Right. Right. Yeah. I mean, I don't have the power to make that happen. I have the power to suggest it, but it's come out of discussions like this. Yeah. And there was a hand over here? Yes.
Yes, please. A question about the research part of it. Do we have any strong evidence that the method of teaching in Singapore was different and made it better? Is it what other variables are here? So, and I know probably there's some evidence.
Right.
How do I get to that evidence there?
I would suggest the report that I referred to that was done by the American Institute for Research. If you do a web search for probably Singapore Math and American Institute for Research, you probably could find it. If you can't find my webpage, then I probably have a link to there. And if that doesn't work, find my email address and write to me and I'll send it to you. But essentially, it talks about all the differences from how our teachers trained. There's much more uniformity there than there is here. How our teachers Oh yeah. I mean, teacher training is a variable, parental support is a variable, teacher pay and respect are a variable. I was told that when Obama went to South Korea and met with the president and talked about, why do your kids do so much better than ours? The president of South Korea said, you want your kids to do better? Pay your teachers more. So, I mean, there's a lot of things that neither you nor I can change overnight. There's been reference made to the professional development part, which I think is really a key piece of this, that you don't just say, here are books, go use them. If you go read that report, there are 4 case studies in there. 2 school systems that were very successful. I worked with one of them. 2 school systems that were failures. And 2 school systems that were failures, it was really, here are the books, go to it. Essentially, if you're moving to a curriculum that says, we want you to teach for understanding, and you yourself as a teacher have never taught that way in mathematics, and you yourself maybe have a lot of gaps in your mathematical knowledge, and you're teaching things by procedure because you don't actually understand them. And one thing that we've done in this country that's been terrible for years is somebody wants to become a teacher, they take all kinds of classes in reading and writing and pedagogy, and then we say, by the way, take a math class. Any math class will do because it's just elementary school mathematics, how hard can it be? Nobody says, it's just reading the Cat in the Hat, how hard could it be? One of the things we've done in Massachusetts, but we're the only state that's done this, is we've changed the certification requirements for new teachers. So now most of the teachers coming out of higher education institutions in Massachusetts have taken 3 math content courses that actually address the math they're going to teach. But if you go to other states, or if you ask current people who are teaching, have taught for more than 10 years, where did you think as an undergraduate? It's little or nothing. And so the piece of getting them comfortable with the math, and from working with your teachers, they're stronger than the average teacher I've worked with. There's no doubt about that, and the level of dedication I find is quite impressive. Because I'm here at 3:30 to 6:30 on Wednesdays, which is why I'm wiped out today. And I know some of them are here at 7 in the morning, if not before, and they're still working hard on math problems after 6 o'clock. So I really applaud them for that. But your question about, a couple of people asked, what's the shift, what's the process? It's challenging at first, there's no doubt about it. But what happens both, I think, for the children and also for the teachers, because the teachers want to see their children in the classes be successful, is once they see it starts working, they really buy into it and they become advocates for it. So, I need to go home. As much as I enjoy talking about this, and probably